let's begin with the concepts, right? So let's take in this way, because before directly jumping towards the Git or any other direct concept, what we are going to do is we just understand the problem statement first. Like, why do we need some version control system, and what is the exact meaning of the version control system, right? And why, what this respective thing is actually solving in, right? So let's begin with the things. Let's say you have one server over here, right? You have created a website, right? And you are a alone person over here who is just developing the respective website, right? So you have written the code, yeah, and you have just written the whole code for the, let's say, HTML and the CSS and the JavaScript to make your website much more intelligent, right? On the other hand, you have just maintaining this respective code locally on your computer, right? So this is the code which you have written, and you're maintaining and just deploying the code on your local machine, right? Let's say you're adding the new features. Let's say for if we'll check for the CSS, you're adding new styling and everything, right? And let's say for the JavaScript, you're just making your website much more intelligent. Let's say some kind of a calculation which you're doing, right? So these are the things which you're adding the features on by enhancing your code and just using and deploying that respective code on your local machine, right? So this is the one. But let's understand the scenario in a much more better way, right? Let's say if you need some else engineer, right? So to just help you out with the proper management, you just hired someone else, right? But the thing is, the engineer should, or the respective person which you have hired, right, also want your code, right? So if this respective code, you can just, let's say, mail the respective code to the engineer, and he can just change the things, and now the engineer can test the code on their laptop. Let's say you have hired 10 more people, right? And they are just, you're sending the mail, or the things are happening like this, and they're just checking and deploying the code on their local systems, right? But we cannot consolidate though these respective uh, contributions of each individual of each respective individual at some specific place. We want something like, let's say, if the developer A added some feature, developer B added a feature, developer C added a feature, but right now they have their own laptops, their own local machines, right? But we want something like just one consolidated space where they can push the data, and we can, just every respective developer will be in sync, that what developer A has added, what developer B has added, what developer C has added, right? So this is the common problem which we need to solve in big organizations, not in the native organizations as well, but uh, in some places, or in some respective scenarios as well, where we have 10, let's say if we have 10 engineers working on a same project, and we want something like to, let's say, whatever that engineer one has given the change or added the feature or removed the feature, we want to be that respective engineer should be in sync with every other engineer, that what respective this respective person is, doing, right? That simply means, let me explain you in much more better way. Let's say we have an engineer, or a person A, or a person B, person C, person D, right? So these are the respective persons who are just working in a company, right? But now let's say what I want is, uh, I want a space over here, and let's say this respective employee added a feature, let's say feature 1, the respective employee B added a feature 2, feature 3, and feature 4. Okay, so these are the respective features added by each respective employee, right? So the thing is, if we'll see that the respective employee A added feature 1, feature 2, feature 3, feature 4. Now I want that respective features to be pushed in a consolidated repository one by one or directly, right? So that all the respective features will be in sync. And B know what A pushed, let's say C know what B pushed, or whatever the things are. They know what they're pushing each other. They are in completely sync up with each other. They are not maintaining the code on their local laptop, right? They're just pushing the data on a central repository where they are syncing up with each other, that what exactly the features are being pushed. I think this is the much more better way to solve the problems, right? So let's understand in this scenario, or in this by understanding all these things, let's take it a step ahead. So Git is an open source version control system. Open source version control system. What exactly is the meaning of version control? We will see this thing in just a minute. But this is also something that is known as distributed. Right? What exactly is the meaning of distributed? We have seen this thing over here. That means the code is distributed, right? And you are just able to access the code from the respective repositories available, right? Sometimes this is also known as the content tracker or the distributed version control system. Now let's understand what exactly is the meaning of version control. Let's understand this scenario in a much more clearer way. We are understanding this part, version control. So version control simply means what? Let's say again, consider one scenario. You have three developers: developer A, developer B, and developer C. Okay. Now let's say you have just written the code, right? And now what you want to do is, let's say developer A is fixing the CSS. Developer B is, let's say, handling the background images. Let's say developer C is handling the JavaScript part. Let's consider this scenario, right? So the thing is, what exactly is the meaning of the version control? So let's say you have just deployed a website with a new CSS styling and JavaScript and everything. The website is now live. People are using it. This is version 1. Okay, this is the version 1 over here. Now what we want is, let's say these respective developers has added some much more functionality, better UI or whatever the updates will be there, and they have pushed the code, and now the website is live with the version 2. But let's say they've asked for the feedback, and some of the people, or the feedback it's received from the users is that the UI should be much more better. We don't like this UI or something like that. So we can travel back in time and we can jump back, right? And yes, this is somewhat called time travel in case of Git. That means we can travel back in the time where we can roll back our systems to the previous versions. This is the native meaning of the version control system. So Git is an open source and distributed, as we have seen, and the version control system. Let's say we have deployed some new version 3, right? Version 4, right? Right? So these are the respective things which we can deploy version by version, right? And let's say if the users are not liking the application or whatever it is, right? And we want to fix some bug. Let's say we have found some typo, right? So let's say we found a typo. Let's say there's some spelling mistake or something like that in one of the page, that we can roll back towards the previous version as well, right? So this is the thing which we need to check on. This is the native concept of what is the core meaning of the version control system in case of Git, right? That means we can roll back, or that means we can jump back towards the stable state where we were, handling the users back then, right? So this is the common thing which we can check on, right? So this is the theory, right? But now let's understand a little bit more regarding the same, right? So there is something that is known as a repository. Okay, what is the meaning of a repository? A developer is sitting over here, right? And this respective developer, is just working on a project, right? And remember this thing, this is the local repository. Local means, that means in the computer of the developer. Right now they're just working and just writing the code and in their local repository, right? And this is the one developer over here. Now we want something like, as we already understood, that we can push the code, right, to some that is to some one consolidated space, and here we call that respective space known as remote repository, right? Let's say there was one developer before, now we have three developers, right? Everyone has their local repository, obviously. They have their local systems where they are just maintaining the code, adding, removing features, whatever they have. Every respective developer have their own native working repository, which is local, right? Local, local, and local, right? So this is the thing which we can understand in such a way. That means each respective developer has their local system where they are just maintaining the code and just adding the features or just testing in their local environment, right? Now after when the respective code is being written or working in an expected manner, we can push the code to the remote repository. These respective developers can push the code, and this term is seriously or the known as push. This is the proper technical term, to push the data to one consolidated repository, right? That means at one respective space, we can handle the whole code from each respective developer, right? So this is the concept, which is the basic concept and native concept, that what is the core meaning of the remote repository. So in case of local repositories as well, we have some properties, right? And what are those properties? Let's say we have this local repository where we are just maintaining the code, local repository. Okay, local repository. And in the local repository, we have something that is known as sections or areas. This is the area 1, this is the area 2, and this is the area 3. And we will understand these things in the hands-on part as well, but let's understand the theory first, right? So in this perspective, areas, this is the very first area is known as a working area. Sorry, right? And the another area is known as staging area. The last area is known as commit area, right? So what is the meaning of working area? Let's say we are just working on the code, right? And we are just adding, deleting the code or whatever, that we are just testing on it, right? And Git is aware that we are testing on it, but still we are just, let's say we want to add some functionality to do some addition, subtraction, multiplication, whatever the things will be there. We are just testing the things out, right? And right now we are in the working area. This is the very first step. And we will see this thing in the hands-on part as well. Just allow me to make you understand the concepts. Now let's say we have finalized some things. We have just added some X, Y, Z features, right? let's say I'm just creating a bash script to just add the users in the Linux system, right? Let's say, or let's consider one scenario to delete the users in the Linux system. I have added a feature that if you do not have the permissions, you cannot delete the user. I've just given some if else conditions, whatever things are, right? So the thing is, I have added some features on this respective code. Now my code seems a bit ready. I can send that respective code to staging area, right? Now, how to send? You will see this thing in just a minute, and that means in the hands-on part. But the code is in the staging area now, right? Now we want to send that respective code. Finally, that means we are committing that we are good to go with the code, and then we will send the code to the commit, right? So these are the things which we need to learn regarding the local repository, that we have three areas, right? That simply means the working area, the staging area, and the commit area, right? So commit area simply means we are ready to push the respective code in the prompt, right? So to understand the staging area, what actually it is, let's take a real world example. Suppose that you are moving to another place and you have to pack your stuff into boxes, and you wouldn't want to mix the items, right? For the, let's say, bathroom, kitchen, or bedroom, or the things are, right? So you will take a box and start putting stuff into it, right? You just took one normal box and you're just putting the data or putting your things into it. And before finally packing, you are just making a label, right? And this is the example. In this example, the box serve as that respective box which has your the stuff in that respective box is known as the staging area, where you're doing your work, crafting your commit, whereas you were done, and then you're packing and labeling it. That means committing the code, right? So this is the basic concept, and how you can just add the files into the staging area, that we will see in the hands-on part, right? So this is just the very uh, high level idea, right? So what actually the things are, handling at the local repository, right? So let's move ahead with the fewer concepts. Now let's begin with the concepts of some hands-on part, right? So how actually which we need to mm, work on, right? So I'm just again repeating one more time. Working area, that means where you are just working on the code, adding, deleting features, whatever the things are, right? Staging means that you have marked the file in the current version to go to your next step. That means this file is okay and you can send to the commit area. Commit means that the data is safely stored in your local database, and that means which is ready to push to the prod, right? So these are the three stages uh, which we need to understand at the very high level as a theory, and on the other hand, we also need to understand this thing at the uh, hands-on part as well. Now let's directly jump on towards the hands-on part so that we can get some hands dirty to understand the Git in a much more better way, right? So now I have just configured one Red Hat server, right, where I'm just install the Git from the very scratch, right, and then I'll just use the respective uh, Git version to make you understand the things, right? So this is my server, which I've already configured. This is a Linux-based Red Hat system, right? So this is the server. Clear this out, right? So now let's understand uh, let's install the Git first in the respective server, right? Just a second. Sudo yum install git -y. So if you are in on the Windows based system, obviously you can download the Git as well, right? So let's say if you want to, let's say, git install, right? You can just search on the Google and you can go towards the this respective page and you can download the Git for, let's say, Windows, Mac, or Linux, with whatever you have, right? So this is the another possible way. Right now, I'm just using I've just deployed an EC2 instance over the on the AWS cloud, where I'm just configuring the Git on this respective. So okay, so this is the one. So if I just go over here and again go towards my server. Let's see if the Git is installed or not. Git -version. Okay, I can see the Git is installed with the version 2.39.2, right? So let's play with the Git, right? Let's create a repository, normal repository. Nothing is over here. As you can see, ls-l, nothing is there, right? But now let's understand how we can create the local repository to track the changes and everything, right? Just a second, let's understand this thing part. Okay, so let's create a repository. Let's name this body as Ashutosh, right? I'm just going into the respective repository, right? Nothing is there. ls, ls-la, nothing is there, right? So now let's understand that how can I make this respective repository a Git repository, local Git repository, where the changes will be tracked, right? So I just want to track the changes, what are the things which I will do on the respective system, right? And then we can understand that how to add the files in the respective areas, right? So this is the thing. So now let's execute the very first command to make this repository a Git repository. So we need to something that is known as initialize the repository. Initialize, right? How can we initialize a local repository as a Git repository? The command is very simple, right? Okay. So we need to execute the command. It is known as git init, right? This is the command which we need to uh, execute. That means git init, and by using the respective command, this uh, repository is initiated as the local Git repository, right? So basically, we are just adding, initializing this respective repo as a native Git repo over here, right? So now let's understand a little bit more. So if I can just, you can see, it is written an initialize empty Git repository in home EC2 user Ashutosh and .git, right? What let's make it a list over here. We cannot see anything, but let's say ls7a. That means we are just listing all hidden items. La. We can see .git is created. Okay, this is a hidden folder, right? And which have some configuration files, and we will see what those respective files are. Let's say indexes, hooks, and let's say edit configurables, etc. Right? But now you understand that how can we initialize a native Git repository, right? But there is something that is known as bare repository. There is something that is known as bare repository, right? So what is the meaning of bare? Bare means where we need to manage the large projects. Those type of respective repositories are known as bare repositories, right? So this is the thing which we need to understand. If you are managing huge amount of code or data in the respective repository, you need to initialize those respective repositories as a bare repositories. This is the best practice which is followed in the industries as well. So the command will be used like this: git init hyphen bare and the name of the respective project. And please remember, as a best practice, we need to give the resolution, or we need to give the extension as .git, right? So this is the thing which we need to follow on to create the uh, bare repository. Let's make it out, right? So if we'll just go over here, right? Let's go back, clear a terminal, and let's say git, and make it git init, right? I'm just going to create a bare project, hyphen bare. Let's say big hyphen project dot git. As you can see, this is created. Now if I just go to the big project, as you can see, LSF and LA, we have much more features. As you can see, hooks, info, objects, references, branches, config, description, and head, right? So these are the things which we this is the natively meant for the big projects, for the industries, right? Their uh, repositories. You can also search on the Google what is the exact meaning of bare. Let's say git bare repositories, right? So bare simply means, that means those respective repositories which are meant for maintaining and managing high production load code. You can find the respective documentation on this respective Git SCM website, right? So now let's jump back and let's see how the things are actually working on. So this is the basic concept, and how you can initialize the respective repositories, right? Okay, I can see in the comments that the resolution should be increased. Just a second. Okay. Let's try to increase the resolution. I'm just pressing the control plus F. Just a second. Increase resolution, increase font size in command prompt. Okay. Is there any command to increase the font size in the prompt? Command prompt, anyone aware? Because I'm not a proper Windows guy. Let's try one more thing. Okay, I don't think that it will gonna increase. Okay, now it is increasing. Awesome. Is it visible now? Can someone please confirm on the chat? Can someone please confirm if the commands are now visible? I can just reiterate whatever we have discussed. This is the confirmation required from your end, students. Yes, no. Okay, let's clear terminal out and again reiterate whatever I have explained you over here, right? So let's go back, cd, clear, and okay. So now let's understand the concept that how you can initialize a Git repository, right? So let's clear the terminal out, right? So now let's create a fresh, again a fresh repository for you guys, mkdir, right? Let's say the name of the repository is dashboard, right? The cd, if I can see ls, nothing is there. ls-la, nothing is there, right? So the thing is, uh, let's initialize the respective repository as a Git repository. So to initialize the respective repository, we need to execute the command that is git init. As simple as that, enter. As we can see, this respective repository is initialized as the Git repository. Now if I can just ls-a, we can see .git folder over here, right? So now let's go back. And as I've already conveyed, we can also initialize a bare repository, which is meant for big production and big code workloads, right? And such respective type of repositories are known as bare repositories. And how to initialize a bare repository? Let's say git init, let's say hyphen bare will be the flag. Let's say big project, big hyphen project. And the best practice is to give .git in the end, right? Enter. If I can just list the items out over here, ls, we can see, let's go to the big project and let's clear the terminal, ls-la. We can see the difference between the normal Git repository and the bare repository. It means that we have some differences, that is branches, config, description, head, hooks, info, objects, references. And we will understand what these respective concepts are in some little bit time. But now you understood that how can we initialize a repository as a Git repository, right? But now the picture comes in. As we have discussed, n number of developers are there. A developer A, developer B, developer C, D, E. But obviously, how can we know which respective developer pushed what? This is the version 1, version 2, right? Let's say we have fixed some JavaScript in this. Let's say we have fixed some Node.js code in this. We have fixed some Express code in this. Now I need to track who made these respective commits, right? So there is something that is known as config. Right? We need to give the configs, that means the, let's say, the name of the user, the email of the user, or whatever things which can be. This is not meant for authentication purposes as of now, but these are the respective changes which will keep the track that who pushed what, right? So the command will be like git config, and we can just configure according to the repositories, and we can configure globally as well. We will see both of these respective things in just a minute. Now, I hope you understand what is the native meaning of config. That means who pushed what. This is the basic and the 10,000 feet of 10,000 view, 10,000 feet view of the respective config concept. That means who pushed what. Let's say a user that is known as Ashu, push the code for CSS. There's another user, let's say, known as Ashish, push the code for, let's say, Node.js. There's another person that is known as Bhuvan, push the code, let's say for JavaScript. And we need to keep the track now. Who pushed what? Ashu pushed for CSS, Ashish pushed for JavaScript, this guy pushed for anything, whatever I was just spoken of. Right? So this is the basic concept of the config, which is handled on the Git level. Right? So now let's understand, let's create a global config user, right, in the Git. Right? So let's come out of this. Right? Let's to execute to make the respective global config user, right? The command will be like git config, right? Uh, user dot name, let's say Ashu Tosh. But now I want this respective user to be global, but not meant for native for any native Git repository. I want this to be global. I'll just give a flag global. Right? And the respective email address, let's say ashu@example.com. Now I want to list around git config -list. As you can see, user.name and user.email will be this one. But let's create another repository, and I can just set up for I can just set up the git config for a proper repository as well. Now if I just go towards the, let's create a repository, let's say new project. Let's just go over here. Right. Now if I want to list them out, git config -list. I am able to list the respective user out because this is meant only for the this is meant for global user. Now, if I just try to add without global flag, what will happen? Git config, right? User.name. Let's say Bhuvan, right? Now I got an error. Why? Because this respective repository is not a native Git repository. To make the respective config user for a proper project, we need to initialize that respective directory as a Git repository first, right? So let's initialize it, git init. Now let's execute the above command. As you can see, this is executed. Now let's add the email address for Bhuvan. Okay. So now let's check them out. So git config -list. As you can see, this is the global one, right? And this is the directory one. Now if I just go out and try to list the command out, I can see only the global one. Why? Because the respective the Ashutosh user is the global user, and the Bhuvan user is only meant for a specific project, right? So this is the concept for the Git config. I hope you understand this respective part, right? So now let's understand a little bit more regarding the staging area. Now, till this respective point, we were working in the working area. We were just maintaining the code or whatever configurations will be there, adding, removing the features. Right now, till this respective point, we were working in, playing with the working area. Now, let's head up to the staging area. Now how to add the respective files in the staging area. This is the concept, right? Till now, we were working in the working area. We are just adding the feature, deleting the feature, or whatever things will be there. Now we want to move towards the staging area. How to move our files and how we want the Git to track the respective files, right? So if I just go back to the repository, let's say go towards the this is repository here. So ls, this is the Git repository as we can see, right? So there's a command that is known as git status. That means none of the commits are there. What is the meaning of this branch and everything? We will understand branching in this in some time. But as we can see, there are no commits, no respective files are there. Let's create a basic file. Let's say vim new file. Let's say Ashutosh -file -1. Right. So let's say this is first file for Git. Right. Let's come out over here. Right. So now if I just execute a git status command, as you can see, Git is tracking our work. Right. So now still we are working in the working area. Right. Please remember that I haven't just sent this respective file Ashutosh-file-1 to work staging area yet. Right now we are still working in the working area. As we can see, untracked files. Right. Let me make you understand in such a scenario where we can understand the concept. The very first thing is on the branch master. What is the meaning of branch? We will understand in just a minute. And on the other hand, we have something that is known as untracked files. Right? Git knows that we have added a file, but that respective file is not yet in the staging area. Git is tracking the file. Obviously, if I just add another file, Git will track that as well because this is the Git repository. Right? So now let's add this respective file to the staging area. So git add the name of the file like this. Now if I'll execute the git status command, as you can see, Git is added the respective file in the staging area. We can also unstage git remove ---- cached, but we will see this respective command in later section, right? But still, as we can see, Git has added the file into the staging area, right? So this is the thing which we need to understand, that how to add the files in the staging area from the working area. So let's play with this thing, right? Let's understand how the things are actually handled at the staging area, right? So as we can, let's execute a command git status -s. That means, as you can see, that means this respective file is being added into the staging area. Let's create another file. Let's say vim or touch Ashutosh-file-2, right? And let's execute the above command git status -s. As we can see, question mark over here, that simply means Git is aware that you have added another file, but it is not being staged yet, right? Or we can also execute a command git status without the -s flag. As we can see, one respective file is in the staging area and another one is being untracked, right? So that let's play a little bit more, and I'm just going to create a repository in this respective Ashutosh repository or Ashutosh directory, and let's see if we will be able to add that respective directory directly into the staging area or not. Let's say mkdir Ashutosh-nested repo, right? I just added it. And let's see if Git is able to track this or not. As you can see, Git is not able to track the directory which we have made. Why this is possible? Why? So the thing over here is Git will only track the files, not the directories, right? If I just create a file in that respective directory, the Git will be able to track, right? So let's do it in this way. Let's say vim nested. Let's say vim nested repo, right? I'm just creating a Python file. Let's say nested.py. Let's say print. This is nested. Now, if I just check the git status command, as you can see, the repository is being tracked, right? This is a common interview question as well, right? So if you will add a directory into the git initialized folder, will that respective repository will be tracked or not? Right? This is the common and basic interview question which can be asked in the version control interviews. Right? If let's say if you're giving the interview for the DevOps engineer, they will surely if they will ask you the concepts of Git, this is the basic and the native question. They will ask you some scenario based questions as well, right? So let's say if you had just added a repository, right? Let's say create a directory, nested directory, and if will that directory will be tracked by Git or not? So the answer will be simple. So if that respective directory have some files, Git will be able to track or otherwise not. Right? So this is the concept. So now let's add these respective files into the staging area. So git add Ashutosh file and Ashutosh. Let's execute the command git status of an s. As we can see, all of the respective files and the directories are being added. And if you want to see some much more output and some verbose command, you can execute git status -b. But this is much more, you know, detailed type of output which is given by the verbose. -v is meant for the verbose, right? So this is the concept which we understood, that how you can add the respective files into the staging area, right? Till this point, if anyone have any questions, I'll just take a 30 seconds of pause. Okay. So now let's do something else. Let me show you the index file. Now, what is the meaning of index file, right? So now let's understand in such a scenario. Let's create another, you know, file in this respective directory. Clear the terminal out. Let's say vim. Let's say license. Right. Enter. Let's say this is the license. Right? So now let's see the git status. As you can see, git is, you know, git is aware that another file is added, but that respective file is being still untracked, right? So let me show you something. If I just do cat, let's go towards the, let's say, git folder now. Let's list them out. As you can see, different folders are there, right? Now, if I just cat the index file, right? As we can see right now, we these respective files are still being tracked by Git. This is the index file. Index file means what? The index file will just let us know which of the respective files are being tracked by Git as of now, right? Let's say in case of production workloads, we don't have exact permissions to execute all of the respective commands. So index file will let you know which of the respective files are being tracked by Git. Another common interview question, what is the meaning of index file, right? In case of Git. Index file will help you out to let you know that what respective files are still being tracked by Git, right? So this is the basic thing. If I just come out, let's clear the terminal out, right? So now let's try to add that respective license file git add. Sorry. If I just see the status, right? As you can see, license file is added. Now, if I just cat dot git plus index, as you can see, this has been tracked, right? So let's come out of this spectrum. Let's clear terminal again, right? So this is another common thing which we need to understand, that how the things are actually working in the staging area, right? So now let's understand some much more theoretical concepts, that how we are actually working. Till now we were just working till the staging area, right? Now let's understand that how you are going to uh, send the respective files into the commit area, right? So let's understand the concepts of commit area now, right? But first let's execute the command git log. As you can see, I cannot execute the command git log because there are no commit made yet. Now we are just moving ahead towards the uh, third part, where we just need to add the files to the commit area now, right? So now let's commit the things out, but let's understand this thing in a proper flow first, right? Let's execute the command git commit first. Git commit. Enter. As you can see, basically a vim editor is automatically opened, right? And I can just give some commit message over here. I can just go into the insert mode. Let's type this is commit, right? That means we just need to give the comment, right? What is the meaning of the comment? Let's understand this thing in such a flow. We are just working towards the commit area now. Let's say you have made the changes into the code, push those respective changes into the staging area. Now that respective code is, the features are working and everything is, everything looks good. Now we want to push the code into this working area. Sorry, the commit area, right? And to send the data into the commit area, we need to pass a message or a comment. That means that respective bug is fixed, anything is fixed, or whatever things are. Let's say developer A is working and developer A fixed the problems for the CSS file. So developer A can write a comment that is fixed CSS, right? So this is the thing which we can check on. That means we can just add the respective commands and the comments which we can pass on when we'll just send the data to the commit area. we can pass the respective comments. Let's say we have just fixed the Python code and the code is production ready. We can pass the comment like say production ready code. Ready code. Right. Such type of comments which we can pass on the when we will just send the files to the commit area. Right. So let's do this in this way. Now we have just added the files. We can see these are the changes to be committed, and we have just added the comment. This is commit. But this is very naive approach. We can just directly do via ad hoc command as well. But let's see this thing. Let's come out of this. As you can see, 4 files have been changed. Right. So now let's add another file, and I'll just show you the ad hoc approach now. So vim, let's say new file. This is new. Right. So now let's check the status. Git status. New file. Git status of an S. Right. This is the one. So now let's add git add new file. Now I'll just commit this file via ad hoc command. Right. So git commit -m. Let's say new file added. Right. So enter. As we can see, this was ad hoc command, right? And now if I just execute the git status command, the working tree is clean. That means still we are on the master branch. What is the meaning of branch? We'll understand in just some time. But as we can see, all the respective changes are being committed, right? So this is the concept of the commit area, right? So this is the basic thing. Now let's execute the git log command. Let's clear the menu first. Git log. As you can see, the 2 commits, and this is the SHA. This is the key, right? And this is the hash code which is used, right? Just to let you know the what type of commits and what the respective keys or the SHA code was there, and we can just track the respective commits with this respective SHA code, right? And as you can see, this is the very first commit which is added, the commit which was added in the VM file, and this is the commit which was added to the via ad hoc command, right? As you can see, the head is now this respective, the latest commit, the head is pointing to the master. Whatever this, we will just understand in just when we will understand the concept of branches, right? So now let's see how can we see that those respective commands which you added. Now let's go to the git over here, cd .git ls. If I just cat this commit editing messages, as we can see, the latest commit was this, right? So this is another common thing which can be asked. What is the meaning of this respective file? That means the comments will be shown over here. Right, now let's go towards the logs. We go to the references, ls. We can see heads. We go to the heads. We can see the master. That means right now we are just where the head is pointing to. The head is pointing to the master branch. So let's understand the concept of branches now. What is the native meaning of branches, and why do we need the branches, and what is the meaning of the branch, right? So let's understand this thing in such a flow, right? Just a second. So let's say we have three developers working: developer A, developer B, and developer C. These three developers are working on the respective code, right? And we have one master developer over here, right? And these respective developers have their own working code. And eventually, obviously, we want the code to be available at single place at some after some time when the code will be in the ready state, right? So these respective, we can just uh, give some space to these respective uh, developers, and that respective space is known as branches. Let's say developer A branch, developer B branch, developer C branch, and these respective developers are working in their own branches. And in the end, whenever the work is done, we can merge the respective branch into the master branch, where final code is available in the master branch, and that concept is known as merge, right? So branches simply means what? Let's say if we can understand this concept like this, each respective person have their own branch, right? And we need to push the data, right? And whatever work we have done towards the major code base, and that is known as a master branch, right? Let's understand this thing in much more better way, right? Let's say there's a master branch over here, master, right? And the developers are working. This is a developer one, developer two have own branch, developer three has own branch, right? This is the, and let's say developer has added developer A has added a feature, developer B has added a feature, developer C has added a feature, right? And the thing is, let's say if we want, let's say we have some one more branch available over here, right? And the things are done and the A, B, and C level. What we can do is we can merge all of these respective branches into one specific branch, and we can merge this respective B branch, let's say, to branch number D, where developer D is working. And D will check all of those respective things, and we can merge their respective code into the master branch. Branching can be difficult to understand at the very first point, right? But still, this is how the concept of branching is being handled at the Git level, right? So branching can be, sometimes complicated to understand in the very first and at the very first interaction of this concept. But don't worry, we will just trying to make it as simple as possible for you guys, right? So one specific space, that means one specific branch, and we want to merge whatever we have done towards the master, that means the native branch. And each respective commit will push or just give us something that is known as a dot. Let's say this is the master branch over here, which we have two commits in this respective master branch as of now. And this is the developer branch, and developer is committing and committing and committing. The things are being worked at the developer branch, and the final thing is there. Now we want to push whatever things which we have done towards the master branch, and we can push on this over here, and we can commit on the master branch. So this is the concept of merge. But merge cannot be simple, never, right? Often, the concept of branching is very much complicated in the production things, right? And as well as the merging concept is not that as simple as which we are seeing. We will also see that how we can create the branches and how we can merge the branches as well. Now let's see the hands-on part and how we can create a branch. All right. So let's go towards the instance. the Git server. Let's come out of this. I'm just creating a complete fresh repository now, right? So let's say mkdir new hyphen project. So now I'm just going to initialize this as a Git repository. This is being initialized, known as the Git repository, right? So now let's create a basic file. Let's say vim, let's say basic. This is basic file, right? So this is the one. Now let's see, let's add this respective file and let's commit it. So let's say git status, as we can see, git add basic. Now let's commit it, git commit -m basic file edit. Right, so this respective thing is now done, right? So now let's see, as we can see right now we are on the master branch. So let's clear the terminal out, say git status. Right now, as we can see, on branch master, right? So now let's create another branch. Let's say git branch, let's say development. The branch is now created, and now if I just check the things out, let's say git. Now if I need to go towards the development branch, so the command is git checkout development. Right now I am into the development branch, right? So how can I verify the git status? Right now, as you can see, we are in a development branch. Now, if we can see, let's execute. Let's go back to the master branch and let me show you something. Git checkout master. Right. So let's execute one command, git log command, and let's see how the things are actually looking at. So git log, and there's a flag that is known as one line to put everything in one line, and let's say decorate. As you can see, this is the SHA, and head is pointing to the master, and we have another branch that is known as development. Right, and the basic file is added in the command or the comment which we have given. Right. So now let's understand. Let's again go back towards the development branch. Right now we are into the development branch now. Right. So now if we just check the git status. Right now we are into the development branch. So let's create a file in this, right? Echo, let's say this is coming from development branch. Okay. So I'm just adding it to a file that is known as, let's say, dev.txt. Right now, if I can just add this file to the staging area, right? And then I'll just send it to the commit area. So it's a git add dev.txt and git commit -n, let's say added by development, enter, right? So this respective file has been committed by the developer branch. Now let's check up with the master branch, right? So if I just go back to the master and let's see how they are behaving. Git checkout master. Right now we are into the master branch and let's list the things out. As you can see, we have only basic file available over here, and in the respective development branch we have created a file that is known as dev.txt, but that respective file is not visible in the master branch. Why? Because we haven't merged them yet, right? So this is the basic thing which we need to understand in the case of branching. That means the data is available in another branch, right, but not in this respective master branch, and we need to merge those respective branches, right? So how can we do this thing, right? So let's execute one command, git merge development. As we can see, this is now merged. If I click on list, we can see basic and the dev as well. And as we can see, fast forward dev.txt, one file change and one insertion. That means all of the respective data, whatever is being available in the development branch, is being merged into the master branch. Right? So if I can see the git status now, and if I can see the git log now, right? So this respective file is being added by development, which is just merged from the development branch to the master branch. But in case of production workloads, this is not as simple as that which we are seeing run, right? Merging can be, tough, right? So the thing is, merging can not be, handled very easily in the production things, right? Right now we are just playing with some text files, but in the production related things where we will face some kind of a conflict, that concept is known as merge conflict. So let's understand the merge conflict now in the theory, right? So let's say a developer has the code written in Python, let's say, and another developer has another branch has written the code with Python, let's say. Let's say they have defined a variable where the value of a is 5, right? And let's say they have defined another variable where the value of a is 7. So which one to choose, either 5 or 7? So this is known as a conflict. Technically, this is known as merge conflict, right? Let's say I'm creating a file, developer A is creating a file, and developer B is creating a file in their respective branches. On the first line, they have given some data. Let's say anything which is written on the first line. On the another branch, the developer added another data where they have added something else on the first line. That means this respective person added something else on the first line. Added something else on the first line. So when we'll try to merge those respective branches, this will not be merged. This will fail, and this will give the conflict error. That which line to choose, either this line or this line. This will conflict, and we need to solve this respective conflict, right? So how can we solve such type of conflicts? The different tools are available as well, right? By which we can solve the merge conflicts as well. That means via GUI or many different tools are available in the market to help the solve the merge conflict as well. The most common one is used as meld, right? So this is the powerful tool which is used to solve the merge conflict, which is commonly used into in the available market today. Right. So now let's see that how the things are actually uh, available at the how can we handle the merge conflicts, and let's create a merge conflict explicitly, and let's see how to proceed with the things now. Right. So let's go back. Right. So let's clear terminal out. Right. And now let's create two different branches. Right. Let's say git branch trial one. Let's say git branch trial two. So I just created two branches, git branch trial one and git branch trial two. These respective two branches are available. Now let's go inside the trial one branch. So git checkout trial one. Right. So now let's add some data. Let's say echo. Let's say anything which we can see. Let's say stuff. Right. And I'm just creating a new file that is known as info.txt. This is added. Right. So let's add to the staging area. Git add info.txt. Right, and let's commit this to the commit area. Git commit -m. This is coming from trial one branch. Okay, this respective thing has been committed. Right, but now let's move ahead towards the uh, trial two branch. Okay, so git checkout trial two. So now let's create the same file echo. Let's say I'm just adding some another data in this respective file echo. Let's say things, and I'm just creating the file with the same name info.txt. That means two developers are working, right, on the same file they're working, and they're adding different data to the same file, and this will create a merge conflict. So let's add the respective uh, file to the staging area and then to the commit area. This is coming from trial to branch. So far so good, right? So now let me head up towards the trial one branch, and I'll just try to merge the trial two branch with this one. So git checkout trial one. Right. So now let's try to merge the respective trial to git merge trial to. As we can see, conflict. Auto merging info.txt conflict. Merge conflict at info.txt. That simply means some error is populating and we need to solve that. So let's click on git log, search for git log. Right. As you can see, the head is still pointing to the master branch, that is the trial one. Sorry, the head is pointing to the trial branch as of now. Right, as I can see, the merge conflict is there. So how can I solve the merge conflict? Right, so automatic merges failed. That means fix the conflicts, and and again we need to commit back the same. Right, so how can we do that? So if I just clear terminal over here and cat info.txt, as we can see, if you can see the greater than sign, that means which is pointing to the current branch, and this is coming from the trial to branch. This is less than. right? So now what we need to do is like just make those respective changes accordingly, right? So vim info.txt, and I'll just delete this line. Okay. This is being added. So I can click on git status. Right now, I just need to again add this to the commit area, sorry, the staging area, and then commit again. So git add info.txt, git commit -m added from try to, right? So this is the thing. Okay, so this is done. So if I'll just cat info.txt, the stuff things has been added. Now I just merge this thing into the master branch, right? So git checkout master, git status. Now I try to merge, git merge trial one. As you can see, fast forward, we were able to merge the respective branches into the master branch after solving the merge conflict as well. If I can just list the things out and click on let's do cat info.txt, we can see all the data which is added by the trial 2 branch is available, as well as added by trial 1 branch is also available, right? And we have added the data into the master branch, right? So this is the basic concept which we have understood regarding the branching, right? So I'll just take a 30 seconds pause if anyone have any kind of doubt. Okay, so now till this respective point, what we have learned, let's understood what till this respective point what we have learned, right? So now let's understand uh, till this point we have seen what is the meaning of version control, why version control is required, right? And what is the meaning of Git, what is the meaning of distributed servers, right? And we already understood the things like uh, the types of the areas available in the local system. Areas we have understood, local system areas. That means the working area, staging area, and the commit area. We have understood the concepts of branching. What is the meaning of master branch, and what is the core, why the things are required at the branching level, right? And how can we merge the branch? What is the meaning of merge conflicts? How can we solve the merge conflicts? Till this respective point, we have learned these respective concepts from the very beginning, right? So now let's try to add some kind of a remote repository, right? So that we can uh, understand that how the things are actually working at the remote level as well, right? So I'll just go towards my GitHub account, right? So we have different remote repositories available in the market as of today, right? So GitHub, Bitbucket, GitLab. If we'll just go up towards some cloud natives concepts, we have code commit, right? Code deploy. In if we talk about the AWS level repositories, right? So mostly in the market, the people are using GitHub, GitLab, or Bitbucket, right? So these are the things which we can use, right? So if you're just targeting towards some cloud native, we can just go with the code commit, right? Or if you're just looking for some kind of a building or things, automation or something, you can always go with the code builder, code deploy type of things, right? But we will not just deep dive over there. But now let's try to set up a remote repository with our local system, right? I just log into my GitHub account. Okay, so I just logged into my respective GitHub account now. So let's see. Let's create a repository in my respective account, right? And I'll just push the data, whatever I'll just do, okay, in from my local system to the respective Git repository, right? So let's say I have some repositories over here, DevOps, whatever the things are. So if I just click on this one, right? So this is the basic repository which is created a long time ago, right? So if I'll just go back over here, and if I'll just go to repositories, right? And if I click on new, right? So now let's try to understand this concept in this way, right? So let's create a repository, normal repository. Let's say new hyphen learn. This is the normal. I'm just giving the normal repository name, right? If I can just go down, we can see public. This repository can be public. That means I can choose who can commit. On the other hand, I can also set up this for the private repository as well. But just for simplicity purposes, I'm just going with the public, right? I can also add some kind of a readme.md file. MD means markdown, right? The git ignore file. What is the concept of git ignore, right? Let's understand this thing in such a way. Let's say if you have added a file that is known as git ignore dot git ignore. Okay, what is the meaning of the git ignore file? Git ignore means what? Let's say you have huge amount of code, right? And if you're working with the Node.js, and with the Node.js, we have a directory address known as node underscore modules. Node underscore modules, right? As you'll execute the command, let's say in the code you have importing Express, Mongoose, or whatever you can think of, right? Some coding experience is required to understand these concepts, right? So if you just, let's say, executing npm install Mongoose, that respective data or the metadata will be added into the node modules file. If you're just installing npm install Express, which is the framework for Node.js, right? Npm install this, npm install that. The things are you're just installing n number of packages, and that respective data will be added into the node modules folder, right? But this is too much heavy folder, man. So you will this maybe sometimes the node modules can be the size can be in the GBs, and we don't want to push that respective GB amount of data towards the repository. Whatever they will be there in the node modules, if the user will execute one command npm install, npm means node package manager. If the respective user will execute a command npm install, automatically whatever modules will be available in the node modules will be installed on the local system. So we don't need to worry about pushing that respective repository. In such scenarios, we will use a git ignore file. Right? Git ignore means what? That means we want to ignore such type of repositories or files that we don't want to push towards the remote repository. This is another basic interview common interview question, that what is the meaning of git ignore file. That means we are ignoring that respective file or directory, and which we don't want to push towards the remote repository. Right? So if I can just again go back towards the UI over here, git ignore. I don't want to add any kind of git ignore. I can just go down. I just create a repository. This respective repository is now created. Right? So if I just need to sync up with this respective repository in my local system over here, right? So if I can just go back, right? And let's say, let's create a new directory, mkdir remote, cd remote, right? So now if I just need to add that respective remote directory, I just need to initialize this directory as a local system. So git init. Right? This is the one. And if I just try to push something, whatever which I'll just process in this respective directory, right? So what I need to do is first I need to add that respective repository into my local system. That means my local system will be completely in sync with the repository which is being created remotely. So git remote add. Now I'll just show you something. Maybe most of the people over here, or if you are familiar with git, right, there's a command which I'm just trying to execute now. That respective command is known as git remote add, and there is something that is known as origin. Please remember that origin is not a keyword. Again, I'm repeating, origin is not a keyword. You can give anything. Most of the people are not aware of this thing, right? They are just they just see origin in the documentation. They use origin, but this is not mandatory to use this keyword. People think that origin is a keyword. No, you can give anything. I can give, let's say bluff. I can give this as well. Whatever I want. I can give apple. Let's say I want. Origin is not a keyword. Again, I'm repeating. Right. So let's do it in a way. Git remote add. Let's say bluff, and I just copy the repository name. Right. Go back. I can just paste it out over here. Now this is in sync. Now, so let's say I need to check git remote -v. That means I can fetch or push the data to my upstream server that is known as bluff. Bluff over here is known as upstream server, right? So this is the thing which we need to use or understand as per the proper understanding purposes, right? So this is the thing which we need to check on, right? Because origin is not the native keyword which is used, but that is only used for the uh, giving the name for the upstream server. You can give anything. Now let's add some file. Let's say vim ashutosh -new, right? So this is coming from local system, right? This is the one. I can just git add ashutosh-new, git commit -m, let's say coming from local server, where this has been added. Now let's push this thing out. But there's an update on the GitHub pushing operations. Now you cannot push directly using your password. Again, I'm repeating. Now you cannot push by using your password. There is something that is known as personal access token in case of GitHub. By using that respective token, only then you can push, right? So I've already generated a personal access token for me, which I will use to push the respective changes. But first, I'll just config my global user, git config hyphen sorry user dot name. Let's say I'll just give my username ashugit 27, which is the global one. Right. And I'll just give my email address as well. Okay, this is now configured, right? So if I just go back to the remote, right? So now I need to use my personal access token over here, right? So just allow me a minute to use my personal access token. I'm just using a personal access token as backend. Just allow me a minute. So how can you generate a personal access token? I'll just explain you in that perspective thing as well. Just allow me a minute. Okay. So I just copied my personal access token, right? And I'm just going back and I just push my code, whatever the data which I've written to the respective repository, right? So git push -u, not origin, anything can be used. I'm using bluff, which I've already configured above. Git remote at bluff, right? And I'm pushing to the master branch. This is asking for my username. I'm just giving my personal access token, enter. I can see this is now pushed. Right now, if I just go back towards my Git over here, if I can just refresh this, as you can see, this is now pushed. This is coming from the local system, right? So now, how let's understand how can you just create your own personal access token, right? So if I just you can go towards your profile, go towards your the settings, and go towards the developer settings over here, right? And you can click on personal access tokens. From here, you can just generate your respective personal access token, right? So this is the thing which you can just work on, right? And you can also there is something that is known as Git pull, right? So now let's say we have just created a repository that is known as new learn, right? Or let's go towards, let's check some another repository. Let's say if I have this one, right? And let's say if I just go towards, let's say, some shell scripts, right? If I just use this, and I just want this respective repository to clone in my local system, right? So I just copy this HTTPS endpoint, go towards my Git server, go back. I just create a new repository, mkdir. Let's say new shell, cd new -shell. Let's say git pull that respective endpoint. As you can see, this is giving us the error. Why? Because the respective local repository should be initialized first as the Git repository. So git init, enter. Now if I just git pull, I want to pull that respective thing. If I can click ls, this respective shell scripts are available in my local system for sync up. Right? So this is the thing, and let's just take a break of 30 seconds and let's see. Any questions? So till now, what we have learned, let's understand. Let's make it a summary over here, right? So today we have learned what. So today we have learned what is the why do we need Git? What is the meaning of the version control system? Version control system, right? And what is the meaning of Git, right? On the other hand, we have also learned that the concepts regarding the uh, local file system. We have understood what is the meaning of working area, what is the meaning of staging area, what is the meaning of commit area. we have understood that how you can add the files in staging area, right? That means and the related concepts as well, right? On the other hand, we also learned at how to send the files from staging to commit area, right? On the other hand, we have also learned the concepts regarding the branches, the what and why of branches, right? We have also learned how to merge the branches, and then we also learned how to solve the merge conflicts on the very high level. And why merge conflicts occur. We have also learned how you can configure remote repository, how to push what is upstream, also we have learned how to generate the personal access token. Okay, this is according to the new GitHub update. Right? So we have learned a lot. That means just to begin up with the things, right? So I think this is fine, and we can end the lecture now. So I hope you really enjoyed the things, and please let me know if anything else is required. Right. So please take care of yourself and have a great day ahead. Bye bye.